Ever pondered if your brain and a computer could have something in common? Well, buckle up, because we're about to dive into the fascinating world of neural networks and artificial intelligence, a realm where the boundaries between human cognition and machine learning blur. Imagine, if you will, the human brain. It's a complex, intricate marvel of nature, teeming with billions of neurons, each connected by synapses. Now envision a computer system, a web of interconnected nodes, each transmitting and receiving data. See a similarity? That's right. In the world of artificial intelligence, this is what we call a neural network. But what exactly is a neural network? In essence, it's a computing system vaguely inspired by the biological neural networks that constitute animal brains. It's a set of algorithms designed to recognize patterns, much like how our brain deciphers the world around us. Let's break it down. Picture a neuron, the fundamental unit of the brain. It receives signals from other neurons via synapses, processes these signals and transmits them to other neurons. Now translate this into the language of computers. In a neural network, nodes or artificial neurons replace biological ones, and connections substitute synapses. Each node receives data, processes it, and passes it on, just like a neuron. And it doesn't stop there. Our brain is a learning machine, constantly adapting and evolving. Neural networks mirror this adaptability. They learn from experience, improving their performance as they process more and more data. This ability to learn and adapt sets neural networks apart, forming the backbone of artificial intelligence technology. Think about it. From voice recognition in your smartphone to recommendation systems in your favorite online shopping platform, neural networks are everywhere, silently revolutionizing the way we live, work, and play. Intriguing, isn't it, how a machine can emulate the workings of our brain? Stay tuned as we delve deeper into this marvel of modern technology. Imagine a network of interconnected nodes. Doesn't it sound like a sci-fi movie? Yet, that's exactly what we're diving into today. The intricacies of a neural network, a marvel of modern technology. Let's start by visualizing a bustling city. Picture the transport network, the veins of the city, if you will. Roads, rail lines, bus routes, all crisscrossing, connecting various points or nodes within the city. Now think of a neural network in a similar way. Each node or neuron is like a stop or station in our city transport network. But instead of passengers, these nodes are processing information. Now onto the layers of a neural network. Just as our city has different zones, residential, commercial, industrial, a neural network has layers. The first is the input layer. This is like the city's outskirts, where everything begins. It's here that the network receives its information, just as passengers start their journeys at the outer stations. The next layer is the hidden layer. Picture it as the busy, bustling heart of the city. This is where the magic happens. The information or passengers are processed, transformed, and passed along. This layer is called hidden because the changes it makes aren't directly seen or understood from the outside, just as a city's inner workings can often be a mystery to those just passing through. Finally, we have the output layer. This is the destination, the final stop. It's the result of all the processing and transformations that have taken place in the hidden layer. It's like the city center, where all routes converge and passengers reach their intended destinations. So you see, a neural network is not so different from a city transport network. It's a series of interconnected nodes, processing and passing along information, just as a city moves and processes its inhabitants. And just like in a city, the efficiency of a neural network depends not on the number of nodes, but on how well they're connected. Just like a city transport network, a neural network is all about the right connections. What if a machine could learn from its mistakes, just like us? Imagine a toddler taking their first steps. They stumble, they fall, but with each step, they learn, they adapt, they get better. Now, picture this process happening in a machine. This is the magic of learning in neural networks. So how does a neural network learn? Well, it's all about training. Like a child learning to walk, a neural network is fed data, or in our analogy, given steps to try. Each piece of data is like an opportunity for the network to take a step, to make a guess, to learn. But here's where it gets interesting. Each time the network makes a guess, it gets feedback. It's told whether its guess was right or wrong. This is akin to the child either successfully taking a step or falling down. With each piece of feedback, the network adjusts its internal parameters. It tweaks them ever so slightly to try and improve its future guesses. This is a continuous process. The network keeps guessing, keeps adjusting, and keeps learning. And just like a child eventually masters walking, the neural network, with enough training, can become incredibly accurate at making the right guesses. Now, you might be wondering, what does this training look like in practice? Well, it's a lot of trial and error, it's a lot of falling down and getting back up. But it's also a lot of progress. And it's this progress, this evolution, that makes neural networks so powerful, because at the end of the day, it's not about the machine simply following commands. It's about the machine learning, adapting, and evolving. It's about the machine becoming better with each iteration, just like us. Isn't it fascinating how a machine can learn and evolve? Ever wondered how your phone's voice assistant gets your accent just right? It's all thanks to neural networks, the unsung heroes of our digital world. These intricate systems are hard at work every day, making our lives easier, more convenient, and often more fun. Let's take voice recognition, for instance. When you ask your phone to set an alarm or send a text, it's a neural network that processes your request. It uses layers of artificial neurons, each trained to recognize different sounds and patterns in human speech. Over time, these networks learn to understand not just words, but the unique way each of us speaks, including our accents, our pitch, even our pauses and inflections. But the magic of neural networks doesn't stop at voice recognition. They're also the power behind image recognition. When you upload a photo to social media, and it suggests tagging your friends, that's a neural network at work. It's been trained on millions of images, learning to identify patterns, shapes, even distinct facial features. And who hasn't marveled at the uncanny accuracy of predictive text? That's yet another practical application of neural networks. They analyze billions of sentences, learning the patterns and structures of language, and use this knowledge to predict what word you're likely to type next. It's like having a little mind reader in your pocket. These examples are just the tip of the iceberg. Neural networks are used in everything from predicting weather patterns to diagnosing medical conditions, from powering self-driving cars to creating stunning works of art. They're behind the scenes, silently shaping our experiences in ways we often don't even realize. So next time you ask your phone a question or it suggests the perfect emoji for your text, remember, you're not talking to a machine. You're interacting with a complex neural network, a marvel of modern technology that's learned to understand you and is always learning, always evolving. Neural networks are not just a concept, they are a reality shaping our lives. Feeling overwhelmed? Let's unravel the complexity together. Neural networks, as we've explored, are a marvel of modern technology. They are designed to mimic the human brain with layers of artificial neurons or nodes that receive, process, and transmit information. Let's take a step back and review. At its core, a neural network is composed of an input layer, one or more hidden layers, and an output layer. Each layer is made up of nodes. These nodes are interconnected, and it's through these connections that they communicate. Just as neurons in our brain fire signals, the nodes in a neural network pass along information. But how do these networks learn? It all begins with the process of training, where the network is fed vast amounts of data. This data is processed through the network's layers, with each node applying a mathematical function to the information it receives. Through this process, the network begins to recognize patterns and make associations. It's similar to how we humans learn, through repeated exposure and association. And these networks aren't just theoretical constructs, they're at work in our everyday lives, powering our favorite apps and technologies. When you ask your phone's voice assistant a question, a neural network is processing your voice, interpreting your words, and formulating a response. They're behind the scenes, making sense of the world's information, helping us navigate our digital lives. So why does this matter? Because understanding neural networks equips us with the knowledge to appreciate the technology that permeates our lives. It allows us to be informed users of technology, aware of the invisible structures that shape our digital experiences. Demystifying neural networks isn't about mastering the mathematical equations or coding languages. It's about understanding the principles that underpin this technology, the structures that allow it to learn and grow, and the myriad ways it impacts our lives. So the next time you use your phone's voice assistant, remember, there's a neural network at work.